Theoretical information.
The utilization of robots are present all across the globe in all sectors of the economy, daily activities, and in our general life. They help assist some of the most difficult tasks in the real world, or assist in things like sweeping the dust. Robots are used in various fields throughout the world, including manufacturing, agriculture, entertainment, education, logistics, along with construction. These numerous fields exist with different types of robots, such as medical robots, who range from assisting surgeons to conducting entire medical procedures. Another application of the robots in the real world are the collaborative robots, or cobots, who are robots that are controlled by a human operator. They are primarily used within manufacturing industries and the automotive industry to accomplish more precise tasks.
A couple of engineering majors relating to robotics are mechanical engineering, electrical engineering, computer science, mechatronics, aerospace engineering, industrial engineering, biomedical engineering, and robotics and automation engineering. The robotics workplace is always constantly evolving, as new robotics technology within automation are conceiving exciting career opportunities for everyone. From micro-credentials to PhDs, robotics helps with everyone and anyone.
Our robot has the capabilities of moving across the playing field to handle the two exhibitions that were presented to us in this year's challenge. Along with this, it is equipped with a scanner and is programmed to be able to detect the colored discs that are out during the 4.5-minute autonomous time period in the first exhibition. For the second exhibition, the robot was given a claw to pick up the discs that were placed on the multi-leveled structure. Once they have been collected, the robot will be driven to release the discs onto the goals around the playing field.
Explaining code, we have different blocks for the sensor to detect the color of the disc. We have a when started for the robot to begin, with a then forever, so that it always constantly detects something during the autonomous challenge. With a if off-code detects red, then that's the end of that code block. Then we have a print red or console inside of quotient next to row, with a spin motor forward for 90 degrees twice, and then wait 3 seconds. We have these blocks so that the sensor can detect the color in which is red, blue, or green, with the motors going 90 degrees forward or reverse to show that it detected color, and a wait 3 seconds to follow and abide by the rules.
Robot information.
This year's challenge consists of 2 expeditions, in which the first expedition is completely autonomous, whilst the second expedition is conducted with teleoperation. The first expedition, which is autonomous, is when the judges that hold 3 different colored discs drop 6 discs onto the viewer for the robot to search. The robot is only required to detect 2 of them. The robot, when detecting the colored disc, must make a sound or remain 3 seconds above the disc. Once finished, the sensor barrier is removed, and it can get points from the multi-level structure, which you can only get 20 points. The second expedition is completed under teleoperation, in which all the barriers are removed at the end of the first expedition. From 4.5 minutes to the end, the robot can collect as many rings as possible, whilst moving freely onto the playing field, but the ring must be able to fit into the goal to ensure the rings count as points.
To handle this year's challenge, the robot is able to move throughout the playing field to complete each task. In order to complete the first exhibition, the robot was programmed to be able to automatically drive around the field until it detects one of the colored discs. Once it finds each of the discs, the robot will wait the required 3 seconds to earn a point. For the second exhibition, the robot will be driven by an operator who will control the robot and its claw to pick up the discs from the multi-level structure and to place them on the goal stationed around the playing field.
There's design changes from a rack and claw that reaches above and below to a 2-joint arm and claw that acts similar to before and rotates on one small and one big gear, in which we finally stumbled upon our peak, where we eloquently and thoroughly examined our flaws, in which we acted upon to fixing and creating our final M.E.S.A design, which has 2 sets of gears of 2 along with an arm of just 1 joint. This 1-joint arm connects to the motor via a small gear and large shaft moving towards a larger gear higher up, and on that same path parallel to the big gear is another small gear leading to a larger one on top again. These sets of gears increase our torque and height limits, breaking what was possible and reaching a whopping 25-inch maximum of vertical reach. This arm was enlightened onto us when remembering how the evolution brought upon giraffes to reach higher trees, and which we utilized to our robot to also reach this type of maximum. Along with the arm is our 2-motor tank drive, which we kept, and our claw. The claw we came up with is 2 alternating L-shapes that grip in the middle, allowing us to obtain the discs easily.
Encountered issues. Some of the encountered pressing issues that constantly slowed us down include torque of the robot, weight of the robot, code of the robot. These difficulties we endured, such as the weight of the robot, slowed us down, as the arm had to be balanced, otherwise risking it to tip downwards and fall. The coding of the robot was a task of constant difficulty, although we would overcome this issue, transforming into amateur coders. The core as well provided accurate reassessments of our layout of the robot. Overall, we were able to overcome these issues and benefited dramatically as we were able to improve our robot.
Some of our improvements include an increase of gears and an increase of torque to be able to generate more force and avoid the risk of being stuck in the middle when lifting your claw up. Not just that, but we also added a better balance for our robot with counterweights at the back to avoid a risk of tipping over, while also changing the joints in our arms from 2 joints to 1 joint to be able to worry less on the problems of our robot when going up and down. A higher limit to our maximum vertical reach was also added to be able to reach the top rings and allow us to gain more points. And these rings we used were additionalized with a grippier claw that we made to be able to grab them without hesitation.